Hey guys, welcome back to chapter 4. In this video, we're going to do a couple examples of basic, simple Lewis structures. So let's start with first with methane. So step 1 is going to be to calculate the total number of valence electrons that we have. So carbon is in group 14 or 4A. So it's got 4 valence electrons. Hydrogen is in group 1. He's got 1 valence electron. And then I'm going to multiply this by 4 because that's what this 4 means. I have 4 of them. So we're going to do 4 plus 4. We've got 8 valence electrons. Step number 2 is going to be to put the skeletal structure onto the paper. So again, think symmetrical. I've got 1 carbon, I've got 4 hydrogens. So my carbon's going to be in the middle, and I'm going to have a hydrogen on each side of that imaginary box. Step number 3 is to distribute electrons, filling octets. I always like to start with bonding pair. So I'm going to draw a bonding pair between carbon and each of these hydrogens. So 1, 2, 3, 4, 5, 6, 7, 8. So I'm stopping because I ran out of electrons. I had 8 electrons to put on the paper, and I put 8 on the paper. Now we need to go back and make sure everybody is happy. So again, hydrogen is happy with a duet. He just wants to touch 2 electrons. Remember, each of these lines represents 2 electrons. So this hydrogen is touching 1, 2. He's good. 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 Now we need to go to carbon. Carbon is not an exception. So carbon wants to touch 8 electrons. So he is touching 2, 4, 6, 8. So we used all the electrons at our disposal. Everybody is happy. This is the Lewis structure for methane. If you are ready, why don't you go ahead and try this carbon tetrachloride. So go ahead and pause the video and see if you can solve it. All right, so for carbon tetrafluoride, the first step is to calculate the total number of valence electrons. So carbon is in group 14 or 4A. He's got 4 valence electrons. Chlorine is in group 17 or 7A. He brings 7 valence electrons. And in this structure, there are 4 of them. So we're going to multiply that by 4. So then we've got 4 plus 28. We've got 28, 29, 30, 32 valence electrons. That's a lot we need to find a home for. All right, so again, we've got carbon and 4 chlorines. So carbon's probably going to be in the middle with the 4 chlorines on either side of that imaginary box. I am going to start with bonding pairs. So we're going to start with 1, 2, 3, 4, 5, 6, 7, 8. Still have a lot of electrons to find a home for. So now I'm going to start putting lone pairs around these terminal atoms until I run out. So I've got 8 electrons on the paper, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So I'm stopping because I ran out of electrons. I've used all 32 and I don't have any more to put on the paper. So now we need to go back and make sure that octets are filled. So looking at this chlorine at the top, chlorine would like to touch 8 valence electrons, and he is touching 2, 4, 6, 8. So he's good. And this chlorine is 2, 4, 6, 8. He's good. This one is 2, 4, 6, 8. He's good. And this one is also 2, 4, 6, 8. So he's good. Last one we need to check is carbon in the middle. So carbon is touching 2, 4, 6, 8. So everybody's octet is fulfilled. Everybody is happy. And this is the Lewis structure for carbon tetrafluoride. So that was a few examples for some pretty easy Lewis structures. In the next videos, we're going to start to get a little bit more complex. I hope you found this helpful.